Let's see. Good evening, everyone. Let's switch on again. I hope everyone has tried the homework problem. Some people did get an answer of MV by QB. Let's see what is the answer. Root 2 MU by QB. So after a long time, Kush has come back. There were rumors like that you ran away from the house. And you're hiding somewhere in Andaman Islands. Anyway, Ishan was saying that. But okay. Let's see how to do this thing. Now see. So when this was projected with speed u, so ux is equal to u, and u vertical component is 0. Now, as this is moving here, this will start bending. Now you need to understand, when you get the maximum x coordinate, means it's going to take a turn. At this point, the velocity will be vy, which is equal to u, and vx becomes equal to 0, and this is your x max. And in this entire process, the magnetic field B is equal to B naught into 1 plus x by B naught into x. Now, why did the speed remain same? Last time I told you, the work done by magnetic force is 0. The speed will never change. So V bar is at any instant is Vx I cap plus Vy j cap, and we get U is equal to U square is Vx square plus Vy square. Since work done by magnetic field is constant, speed remains constant. So initially Ux is 0, finally Vx is 0. And we know force is equal to QV cross V. And this can be written as mass into acceleration Ax I cap plus mass into acceleration Ay j cap, and QV cross B, this will be QVx B naught x, that is I cross minus k. I cross minus k is j plus QVy B naught x, that would be j cross k, so that is minus I. I simply did V cross B. Right, now here what I'm interested is the horizontal component. So Ax would be minus QVy B naught x by m. So this I can write it as Vx dVx by dx. Because I want to find x coordinate, my integration should be in terms of x. This is minus QB naught by m. What is Vy? So Vy is root over u square minus Vx square into x. So I substituted Vy from here. So I'm trying to get everything in terms of x, Vx and x coordinate and stuff. So if I integrate this thing, I need to integrate. I'll just show it in the next page, but have a look at this. If you got till here, it is over. Now it is only max. So I'm getting everything in terms of Vx and x. So initially Vx is u and finally it is 0, and the x coordinate will be 0 to x max. So the point when it is taking a turn, this thing will have a Vx is 0. So that would be Vx dVx root over u square minus Vx square is equal to, this is minus QB naught by m. And this will be x dx. Integral. This will go from 0 to x max. This is initially Vx is u to 0. Integration by substitution. Put u square minus vx square is equal to t square minus 2vx dvx is equal to 2t dt. Substitute here, this would be minus t dt by t, and limits will be when vx is u, t is 0, and vx is 0, t is u. And this side it will be minus qb naught by m x max square by 2. Minus minus goes off, tt goes off, this will become u 2mu by qb naught ka root is x max. There, check your answer. Lakshika, you got it. Please have a look at this thing. Meaning, once you got till here, job's done. It is just max after this. So at every instant, right, the x is changing. What remains constant throughout the entire process is the speed. So let the velocity at any instant be vx I cap plus v by j cap, but the magnitude is constant. The reason why I didn't take ay, I could have taken ay also. I would have got the answer. Same thing. But then I would try to replace everything in terms of y. Please check. All clear with the steps? Any doubts on this? Please ask me. Clear? Let's see one more. Turn in the page. So we have a patch of magnetic field. A particle is entering with speed u at an angle alpha, charge q, mass m. This thing goes in a speed u angle alpha qb. This thing goes like this and comes out here. This angle is beta. The thickness of this thing is d. The magnetic field is b, constant, and the speed is u. Find the relation between alpha and beta. A particle q and mass m enters into a region of magnetic field at angle alpha and leaves at beta. Find the relation between alpha and beta and the average force. Let's get this. Force is constant. Is it? Direction also matters, God. Try. I'll give you a minute. It's a good one. I'm sure you must have seen the standard question that is like enters like this and leaves like this. Uh, Something similar. This is not. It's based on that only, but this is a better one. Try. I'll give you a minute more. Let's see. See. So when you're entering and leaving, right, understand one thing. In a constant magnetic field, it will be always a circle. Right? So at this point, when you're entering, the center would be somewhere here. It should be perpendicular. This is your normal. At this point, if you draw perpendicular to this guy, so this is how it looks. So center must be somewhere here. Make sense? It's perpendicular to the, when you enter, it is perpendicular. When you're leaving also, the force must be perpendicular. And the point where both the forces meet will be your center. Now, if you take that angle as beta, this is 90, this is 90 minus beta. So with the vertical, this whole angle will be beta. Similarly, here, if this angle is alpha, that is 90. This is 90 minus alpha. This angle will be alpha. So if I take this distance to be x, and this green line ka length is radius r. Now from that triangle, you can clearly see sine alpha is nothing but x by, sine alpha is x by r. Sine beta is x plus d by r. Subtract them. We get sine beta minus sine alpha is d by r. Easy? And what is average force? Average force is simply the change in momentum by time taken, which is m into the change in velocity by time. So here you are entering at an angle alpha, and you're leaving at an angle beta. So you have velocity vectors rotated by an angle. Let's call it delta, which is a deviation. Delta is beta minus alpha. This is the deviation angle. So V final minus V initial. The change in velocity vector will be 2V sine delta by 2. Maybe I'll do one thing. I'll do that in the next page. But have a look at this here. You can't use same Vx Vy concept here, right? Previous question also, how did I use that? I didn't say Vx is V. I never said Vx is constant everywhere. You can say you enter with speed u, you leave with speed u. इतना तो बोल सकते हो. You're also the speed will be same u only. You
Yeah,
can't say
sure. So
anything more
we
than that.
can find Vx and Vy after it covers a
हाँ
distance.
कर सकते हो, yeah, ये कर सकते हो. Right. So that you can do.
So how do you know that radius is greater than d?
वो case है. We will take that case where if that radius is greater than d, then this would have gone and would have come out like this. That would be this
No,
question.
the case which you've done right now, that is radius greater than d, right?
It would become like this, na? So we are taking a case here. D is R is greater than that D case.
Yeah, exactly.
Yeah. So we are assuming that case doesn't happen. Like there is a possibility. You'll enter and
Okay.
you'll come out. We are not taking that case. That case would have been this problem. Case B.
Right, got it.
So how do you find this thing? So we have V initial. So V final. So you don't want to do vectors. What she said, you can do that actually. So initially it is U. This is alpha. So V initial is U cos alpha I cap plus U sin alpha J cap. V final would be U cos beta I cap plus U cos alpha J cap. And then you can find the change in momentum, which is M into delta V. And how do you get time? Beta sin beta ना. Time कैसा आएगा? Time will be R into that length beta minus alpha by U, the arc length. If you see, this angle would be beta minus alpha. That is also called as deviation. So the particle deviated by this angle. So this arc length is R into delta, and the time taken will be speed is constant. So R delta by U. Now, when you actually simplify that cos alpha, cos beta, everything, that would turn out like this only. Whenever you have a body going with a constant velocity and it turns, and the angle is delta between them, you can clearly see it's an isosceles triangle. The change in velocity would be 2v sine delta by 2. That's what I was trying to say. That remember that's a standard question in vectors also. If you remember, a particle is going in a circle and rotates by an angle 60 degrees. Find the change in speed. Find the average speed or average velocity, the magnitude of average velocity. That is the thing. So this turns out to be 2mu sine delta by 2 by r delta. I will leave it there. Narca value is mv by qb. Is this clear, everyone? Now, using this, we can do even something better. This would be a better result. What if you have multiple sections like this? So all this is valid under the assumption that delta doesn't exceed, the beta should not become beta. This angle should be less than 90 degrees. If beta becomes greater than 90 means what? Beta is turned inside. We will not handle that case. So this is for valid for, that's what Arjun was saying, beta less than equal to 90 degrees. If beta exceeds 90, this will go inside and this whole thing goes for a toss.
सर यहाँ पे d exceeds r, ऊपर का sin beta will exceed 1 ना, तो बात ही खत्म हो गई.
क्या हो गया?
d exceeds
हाँ
r.
नहीं, but this is a general, see, हमने general result derive किया, right? If you try to substitute the value and if you get sin beta greater than 1, that's what it means. I'm just trying to show you that.
Okay, sir.
Now, let's say you have a situation like this. Let's say here it is B1, here it is B2, here it is B3, Here it is B4 and so on. This is Bn. So now when this particle enters here, let's say if this enters at an angle theta, so this goes like this here. This is alpha 1. Now this will take a turn like this. This is alpha 2. Getting it? And then it will go like this. This is alpha 3 and so on. Finally, when it comes out, let's call it theta alpha n. Right? So if you try to write this, this is the formula how it looks. So the first one is sine alpha 1 minus sine theta is equal to whatever is this distance. Let's say this distance is d1, this distance is d2, this distance is d3, and so on. So your general formula would be d1 by b1, d1 by r1, where r1 is mv by qb. The second one would be sine alpha 2 minus sine alpha 1. This will be minus d2 by r2 because the field direction has changed, and so on. This will be finally sine alpha n minus sine alpha n minus 1. This will be again dn by rn, depending on whether n is even or odd. So when I add all of them, you can see alpha 1, alpha 2, everything will cancel. You end up with sine. That final angle would be alpha n minus theta, that is that initial angle, is the summation of di by this thing. So d1 by r1 minus d2 by r2, d3 by r3, d4 by r4, and so on till dn by rn. Now, if all are in the same direction, right, all will add up. You're getting it? If everything was b1, b2, b3 all in same direction, then you'll just put a plus sign everywhere. If the field is reversing, then you'll put a minus sign. Hope you're getting it. And what is the deviation here? So on till dn by rn. Deviation delta would be the final angle alpha n minus theta. That's your deviation angle. And again, this is all is valid when alpha n must be less than equal to 90 degrees. If alpha n has gone more than 90, means it will turn back. This is a neat result. Even if you have multiple, sections, you can use this. Clear? This is a useful result. Now I can make this even better. Let's say you have a region where the magnetic field is varying. If you have a variable B. So then what we can do, we can choose a small thin section here, dx, and let's say the magnetic field is bx. Now you can see that formula there. We got sine alpha n minus sine theta is sigma di by ri. Here all are in same direction. We'll assume at least the direction is same, only the magnitude is varying. So from here we can say sine theta final minus sine theta initial So in that place, right, you'll get integral. So d is the thickness of the film. So here it will become dx, and r is nothing but mv by qb. So the radius of curvature is changing at every instant. So speed though will not change, mu by qbx. There, that's your formula. This is a variable magnetic field region. R is equal to mu by qbx. So let's say someone enters inside like this with speed u. This is the situation. You can just take an example. Let's say this is d and this is equal to b naught x. X is equal to 0, x is equal to d, and let this thing enter straight with speed u. So this thing would go off like this, and this is your delta. So from our formula, we'll get sine delta minus sine 0 is equal to integral q by mu b naught x dx from 0 to d. You'll get sine delta is equal to q b naught d square by 2mu. So I just need to take the whatever beta value is given, dump it there, and you'll get the answer. So it's the same as the previous one, but here what I did was I'm making the sections much smaller, dx thickness. So suddenly that sigma will become integral, and d ka place me will get dx. I hope this is making sense. So you can make this cross-section thing up to this level. You can bring up to integration here. It's a good one. The standard mains level question is that you enter horizontal and you leave here. That's a standard one. We changed it a bit. Have a look at this. So this is your general formula in case of a varying magnetic field. So this is a deviation in a varying magnetic field. All clear with this? So this is case 3. Till now, what we did all was case 3. The case 1 was a straightforward thing, and case 3 was a circle thing. Next thing, case 4. Velocity is at an angle to magnetic field. So I can divide this into 2 parts. V sine theta plus V cos theta. Now, if you look at this, this is case 3 actually. V and V are perpendicular. This is case 2. Both are parallel. So this thing will make it go in a circle where radius is equal to mv by qb. But V ka placement now we have V sine theta. And if you send parallelly, it will go in a straight line. Now, when you combine these two, what you get is a helix. So case 4 is a helix. So the distance between 2 threads here is called pitch. So pitch is nothing but the distance traveled in one time period. And the time period ka formula is how much? 2 pi m by qb. Time period is independent of velocity. And what is the pitch then? Pitch is the horizontal velocity u cos theta into time period. There, have a look at this. So case 4, if you're sending V at an angle theta, you get a helix.
The helix is like the diagonal of a rectangle or something, right?
समथिंग क्या पंच यू नो, जब ये सब भूल गया तो जाके रिवीजन करना
जैसे
चाहिए.
SHM में था बट आई फॉरगॉट.
SHM में नहीं था. Yesterday I was teaching your juniors and I was scolding them.
It
And now
was
I
there
have
in
to scold you
SHM
guys
actually.
also.
It was
SHM
there.
में कहाँ पे? SHM का ना था वो.
It was there. It was sliding down then elastic collision with the
It was
water.
not an SHM question. It was कल ही सिखा रहा था उनको juniors को.
हाँ, so this is an SHM का notes also.
Nah. You know when is the first time it came? Kinematics.
Oh.
Then it came in NLM. Then it came in circular motion. SHM is just there. What you're saying was this. If you take a rectangle and if you draw a diagonal and if you fold this rectangle into a cylinder, this thing will be an helix.
Acha, got it.
That was a property.
Yeah.
But ये important नहीं है यहाँ पे. Let's get now clear with this thing. Let's see a question on this. So this is X, this is Y. Magnetic field is Bi cap, constant. Particle is projected with V at an angle theta. So this velocity is in XY plane, huh? Particle projected in XY plane. So that's your z-axis. Find the coordinates at time t. Find x coordinate, y coordinate, z coordinate at time t. That you do, you got everything about the helix. They can ask you multiple questions. When will it cross, x-axis again? What is the distance? What is the displacement? You can find all those. Find the coordinates. Hope the question was clear. The particle is in xy plane. So first of all, try to visualize how is this thing moving in the first place. Now, get the remaining two. Nice. जो easy है वो लेके आना नहीं है. You are like the kid, mom keeps, rice and sweets. So first the kid eats the sweets and then he starts crying, I don't want to eat rice. Ever did that?
Oh, yes, sir.
So don't finish all the easy ones. Do the tough ones first. Y and Z nikalo. X is the easiest one to find. Get the rest. SHM nahi hai record. You have to find the angle. Yes, you have to find the angle. Why did you think the question was tough? मैं सब दे दिया तो what will you guys do? फाइंड एंगल भी निकालना है. SHM नहीं है God. Just now I said it is a helix. Why is a helix in SHM? SHM means what?
So
It is
no,
oscillating like this, क्या?
it is like a circle on the YZ plane now. So if you take the projection
So
of the circle, it will be SHM only on
ठीक
the
है.
y-axis.
Makes sense what you're saying. So what are the final coordinates?
I didn't see the like कुछ तो गड़बड़
Kar-
की है मैंने. What have I done?
First of all, did you guys see how is the particle moving? See whether you got this or not. So this circle, right? If you look at the vertical component, this is V sine theta. This is your magnetic field. The circle is going like this. You're getting it? The circle is going into the plane. It is on the minus Z axis. This is X. This is Y. This is Z. This is the minus Z axis. And the center is somewhere here, which is 0, 0, minus R. I hope you're
So
getting
V
the
cross
center of
B
the
होता है
circle.
ना, so it should be on the plus Z axis only.
Yeah.
It's V cross B, right? So the V cross B will be on the plus Z axis, no?
Right. So now if you look at this in another view, right? This is your Y, this is your Z. Means I'm turning it towards you. Arey God, I'll punch you. J cross I क्या होता है? Minus K.
Sorry. समझ गया.
So this is X. Huh? Are you getting how it is? X is coming out. I just turned the whole diagram in a thing. So this is your circle. Is the thing clear? Now at any instant, you're going which way? You started with this speed, right? So you're going like this with a speed of V sine theta. So at any instant, this is the angle theta. So angular velocity omega is nothing but V sine theta by radius. Sorry, let's take this as alpha. Theta I'm already using there. So that angle alpha is nothing but omega t. Sure. And radius r is nothing but mv sine theta by qb. So from here, if I drop a perpendicular, this would give me a z coordinate, which would be how much? This is r cos alpha. So this balance would be r minus r cos alpha. And the vertical coordinate would be r sine alpha. So there, your y coordinate is r sine alpha. Your z coordinate is minus of r minus r cos alpha. X coordinate is the easiest one. X coordinate is v cos theta into time. Because the reason you're going along x-axis is because of v cos theta, undeviated. Is this clear, everyone? Check, it's not tough, but you should just know like how it is going. First thing is that trajectory and this thing. The center of the circle is on the minus z axis. 0, 0, minus r. Clear, na, Simon? Got this? This is what you're saying, how to get the angle. You can, the speed is constant. From there, you can figure it out. Clear, everyone? Any doubts on this? Next one. Z coordinate. Yeah. Next thing. Case 5. Let's say we also have an electric field now. So we have an electric field in the region E is not 0, B is not 0, and let's say they are mutually perpendicular. This is a special case. It could have been anything. So let's say velocity is V. the magnetic field is B and the electric field is along the y-axis. So now on this particle, if you look at the forces, the electric force will be in the upward direction, and QV cross B, this would be in the downward direction. Now, if QVB becomes equal to QE, so for this field, E is equal to VB, there'll be no deflection. It will go in a straight line. Quite a useful result, actually. I'll show you multiple reasons. It's especially useful this way. So the velocity is given by E by B. This is your minimum speed for no deflection. I'll tell you why it's a minimum speed. You can have more than this also, but still you won't deflect. Now, the biggest advantage of this formula, you know what? Units and dimensions. Find the dimensions of electric field by magnetic field. Normally, if you try to do this, you will die. Electric field ka dimensions, magnetic field ka dimensions. But the answer is pretty nice. It's velocity LT minus 1. So that way, it is pretty useful in units and dimensions. And later on, we will see actually E by B will come to be speed of light for electromagnetic waves. Now here, now there is a case where, let's say you have velocity Vx, you have velocity Vy, and let's say we have a magnetic field B and we have an electric field. I just reversed it. Now, if you look at here, the F magnetic force would be Q Vxb k cap. The Y component is useless. Similarly, F electric would be QE minus k cap. So for no deflection, this is the actual condition. Vx must satisfy E by B. And Vy can be anything. It won't affect the problem. Therefore, the speed can be greater than E by B. So the speed of the particle can be greater than equal to E by B. So this thing, what we derived here is a minimum speed condition. So be careful. They'll ask like this, but there is no deflection, the speed is V by B. Is it like, can you have 2V E by B and still it not deflect? Yes, it's possible. Clear, everyone? Now, if you see that Vy is parallel to B, so magnetic field will do nothing, and Vy is perpendicular to E, so E also will do nothing. Now, this case 5 is especially important because you have an experiment called J.J. Thomson experiment for finding specific charge. So let's see what is the experiment. Turning the page. Any doubts on this? Thomson experiment to find specific charge. Specific charge is nothing but ratio of Q by M. Q by M ratio. Yeah, velocity selector, mass selector, you can say that. So let's see what is the diagram here. There. So this setup, right? We have two parallel plates here. These red ones are parallel plates. They're connected by a battery, and the electric field would be potential difference by distance, where V is the voltage of the battery. So now first what you do, you send some charged particles from here. So we are going Q and M. So generally what we use, right, for alpha particles or anything, we use radioactive sources. Now you tell me, when a radioactive source is emitting alpha particles, do you know the speed of those alpha particles? We can't find them directly. So charge, this particles like alpha particles and all emitted from the radioactive sources, alpha particles or beta particles, emitted have unknown speed. So that's our first problem. We don't know the speed only. So what we do, we adjust the electric and the magnetic field, and in the region there is an electric and magnetic fields. So we keep on adjusting them till this beam will go in a straight line and focuses at the center. So at this instant, we know this is QE. Actually here, this is QEB and this is QE. I think I wrote reverse, but okay. Now think about it. If these two values are not matching, what would have happened? This thing would have deflected like this or deflected like this, right? So the beams would have deflected, they won't hit at the center. So you keep adjusting the values. Technically, we normally adjust E only. That is easy to change because of the battery. We adjust electric field and magnetic field till there is no deflection. And from there, we can get the velocity is E by V. Clear? So there you got the velocity. Then what we do, then we switch off the magnetic field. So let's say these are the plates, length L. So let this be positive. This be the negative. And we have an electric field in the region E. Now these particles here, which are going. So let's say if you had sent inside a positive particle with Q, mass M, and speed U. Now this guy, because of repulsion, will start deviating and goes off like this. And here we keep a screen. Mostly a fluorescent screen. So when the particle touches there, you can see, that whole thing starts shining there. So this will start bending till here. And after this point, right, there's no electric field also. This will go in a straight line. Is that making sense? Once you come out of the plates, there is no field anymore. It goes in a straight line. So if you take this angle to be some alpha, and this deflection, though we can find, this you can measure from the experiment. Let's say this is D. So at any instant, what are the forces acting on this? So this will behave like as if projectile motion. Acceleration is given by QE by M. So in the horizontal distance, length L, L is equal to U into T. So from here we get the time. And the vertical displacement would be, so Vy will be Uy plus Ayt. So Ayt and Ay is QE by M into L by U. That's your vertical velocity. So at this instant, I know my Vx, which will not change, which is U. I know my Vy. So from here, I'll get tan alpha, which is Vx by Vy, Vy by Vx. And I know this deflection, that's your y coordinate. Y is equal to half ay t square. That would be your y coordinate. There, you got everything here. So this is y. I know alpha, I know d, and I know the distance from the screen. Let's call this capital D. And from there, I can get tan alpha is equal to d minus vy capital D. Now, in this experiment, I know alpha, I know small d, I know y, I know everything. You'll get stuck with q by m ka ratio here. If you simplify everything, you'll end up with q by m is equal to something. Is this thing clear, everyone? So basically, once you switch off the magnetic field, it'll just behave like a projectile motion. The field is pushing it down, the beam will deviate. Once it comes out of the plate, it'll go in a straight line. So this would be a straight line. There's no force outside. So once it comes out of the plates, it becomes a straight line. This will be useful to find the isotopes. Let's say if you take two isotopes, right, like sodium Na24 and Na23, if you see, because the mass is slightly different, they'll have slightly different deflections. There's a small difference in distance. Since both have same charge, right, and mass is slightly different, from that deflection, you can find the mass of the isotopes. Right, it goes in a line. There, this is the Thomson experiment. Is the setup clear, everyone? So the first part of the setup is to find the velocity. Because what you're getting out of the source, you have no idea. And once you got the velocity, then switch off the magnetic field and then just becomes like a projectile motion. All clear with this?
Yes, sir, clear.
You can switch off either field to do the calculations, right?
Electric field is safer. Magnetic field is, if you can see how it is at a circle, it becomes pretty messy, right? When it comes up.
Yeah, right.
Electric field parallel plates, now you can control it pretty well. Yeah, next thing. Case 6. This is same as that. So V is like this, theta is like this, and the electric field is like this. Again, the same story here. This is B. V sine theta, V cos theta, and this is E. This will go in a circle and this will go in a line which is accelerating now. This would be x is equal to V cos theta time plus half acceleration, which is EQ by M t square. This will go in a circle. R is equal to mv sine theta by qb. So you get a helix which is increasing pitch. There. Now, so if you combine this, we define something called Lorentz force. In the beginning, remember, we had a discussion. Sometimes, depending on the situation, you can see only electric force or magnetic force. So Lorentz force is given by QV cross B plus QV. So this is your magnetic force component. This is your electric force. So the combination of both of them together is called the Lorentz force. Now, why this is important is because the first thing, electric and magnetic fields are time dependent. Later on, we will see in EM waves. Frame dependent. The time varying electric field will produce a magnetic field. Time varying magnetic will produce an electric field. So if someone just gives you an electric field which is changing with time and asks you the force, you need to understand that is producing an electric field which you're not looking into. So things will get messed up. You won't get an answers. So that we have a relation in electromagnetic induction. There we will see induced electric fields. So Lorentz force obeys Newton's third law. But sometimes what happens, right? You take only electric force, just like I was saying, you have a time varying magnetic field and that produces an electric field and that you didn't include in the picture. Then it feels like, the third law is failing. In certain cases, if we take only the magnetic or electric field, the third law might not be valid. You have to include both. So especially you have to be careful whenever you have a time varying fields. Previous page here. Clear? Next one. Any doubt so far? The next one is a good question. That would be proper advanced question. Let's see. X-axis, y-axis, you kept a particle here, qm initially at rest. You have a magnetic field B out of the plane and you have an electric field D in the region. So first one, draw the trajectory. Find the speed when the particle is at x comma y. So till here they can ask even at a main level, it's a good question. Find the velocity at x comma y. Now if I ask you find x and y coordinates as function of time, it becomes pretty deadly. Let's get this. The first two are good. Matlab, you can expect them even at a mains also, even at advanced also, they can ask this as a more than one choice question in part. But you ask me x and y coordinates, it has to be paragraph. It takes time. More of a max oriented. Let's give it a try. It's a good one. Did you guys get the trajectory? Yeah, it's a cycloid and yeah, that's the velocity. Now, if you see the trajectory here, so initially when you start, there's no velocity, so there's no magnetic force. So it will go in the upward direction, but as it goes in the upward direction, so at any instant here, if you see your velocity is v, the magnetic force will start dragging you inside. So this will be your QVB. And the electric force will be upward. I'll just call it Fe. But as you keep going up, your speed will increase more and more. At one point, at this position, your speed is maximum. I'll just call it Fmag. Fm. Now, because the velocity is so high, the magnetic force will be so high. Now this will start turning inside. Now, if you observe, once it starts turning inside, the electric field and the velocity are having an obtuse angle. The particle slows down and finally it comes to rest again. And again, the motion repeats. Is this making sense, everyone? So as the y coordinate increases, speed increases because electric field is the only one who does the work. Speed increases and this results in, and F magnetic force increases. So the particle will start turning down. It can never happen, na Saina? Think about it. If FB is less than FE, matlab, it still didn't reach the maximum point. That means it will still keep going up, isn't it? Then the speed will keep on increasing. So eventually you'll reach a situation where it has to turn. You don't have an option. The only difference will be maybe this will be pretty big circle then, matlab, pretty big cycloid. It's not a circle. And the particle starts turning back. And comes to rest on the x-axis again. It again exactly stops on the x-axis, again starts moving. Now at any instant here, if you look at the speed, v, and the coordinates are x comma y, work done by all forces is change in kinetic energy. So that would be work done by electric plus work done by magnetic. Should be half mv square, initially speed is 0. But we know work done by magnetic is 0. So EQ into y, the force is constant, so it only like the vertical displacement is half mv square. Getting the speed is easy. Root over 2 EQy by m. Speed is the easiest part because the only force which does work done is electric field, and electric field is in j cap. So you should take only the j cap displacement. X coordinate doesn't matter. Do have a look at this. Clear, everyone? Now, how do we get the coordinates? And Utsa, and that what is V naught? And I asked you x and y coordinates. You gave the velocities, and you didn't tell me what is V naught.
So let us find that.
How do we find the coordinates? Think, get me the equation. It's more of a max oriented. Try for 2 minutes, then I'll show you. So this motion is periodic. It just keeps jumping. So let's say at any instant velocity is v, magnetic field and the electric field. So let the velocity v be vx I cap and vy j cap. And if you look at the force here, F would be qv cross b plus qv in the Lorentz force. So force would be qv cross b. B is what? B k cap, right? So I cross k. So qvb I cross k. So this would be qvxb. I cross k is minus j. qvyb, j cross k is I cap. And the electric field will be qe j cap. So from here you can see the ax will be only the I cap component, which is q v y b by m. This is your acceleration in the y direction. Acceleration in the y direction will be the force on this. So that would be qe minus q vxb by m. This is your force in this thing. And if you notice here, the acceleration in x is depending on velocity in y. Acceleration in y is depending on velocity on x. V naught is the amplitude. नहीं आएगा amplitude. SHM से see SHM equations you'll never get amplitude. You'll get omega. And if you look at the initial conditions here, what are the initial conditions? Initial conditions: Vx is 0, Vy is 0, Ax is 0. There's no acceleration in the bottle, but Ay is Qe by m. There is only electric force ka acceleration. Have a look at the equations still here. Physics got over here. Now comes Max. Now let's take that second equation there. Ay is Q by m E minus Vxb. Differentiate on both sides. So the left hand side will become d square Vy by dt square. It's already one differential to a double differential. This would be minus qb by m dvx by dt, which is ax. But you also know from the first equation, ax is qvy by m. It will be d square Vy by dt square would be minus qb by m whole square into Vy. Now this looks like an SHM, isn't it? It's a differential solution there. So the solution for this thing is Vy is equal to V naught sine omega t plus phi. This looks like SHM. Where omega is given by qb by m. Great, I know omega. Now at t0, Vy is 0. Therefore, the phase angle is also 0. Perfect. So I got Vy is equal to V naught sine omega t. Now if I differentiate this, Ay acceleration dy by dt, this would be V naught omega cos omega t. Now at t is equal to 0, I know Ay is qe by m. This turns out to be V naught omega. From here, I'll get V naught ka value. This is q by m omega. Omega is qb by m. So qb, there we got V naught is equal to E by B. That is the V naught ka value. So the velocity in the y direction is given by E by B sine omega t, where omega is qb by m into time. Vy आ गया, वहीं से y coordinate आ जाएगा. We need to find Vx. How will you find Vx? Take Vy from here and substitute in this thing and double integrate. Have a look at this page, I'll show you. Clear, everyone? Then, so Vy, I'll just keep it in terms of V0 only. V0 sine omega t. So V0 is E by B. Omega is QB by M. Integrate this, you will end up with dy is equal to V0 sine omega dt 0 to y, 0 to t. You will get y coordinate is V0 by omega. Sine can integral is minus cos omega t. And when you put 0, cos 0 is not 0. This is V0 minus 1 minus cos omega t. That's a y coordinate. And then from the equation 1, we also know ax is qb by m into vy. If I substitute here, I'll get qb by m into v0 sine omega t. This is nothing but dvx by dt. This qb by m is nothing but actually omega only. Integrate this. You'll get vx is equal to v0. That will be cos omega t. Again, limit 0 to t, cos is not 0, 1 minus cos omega t. Integrate this again, you'll end up with x coordinate would be v0 into omega. This will be t minus sine omega t into 1 omega v0 into t minus v0 omega cos omega t. I'll just integrate this thing. v0 dt minus v0 cos omega t dt. 0 to t and 0 to t. The x coordinate would be v0 into time minus that guy would be v0 by omega sine omega t. That's your answer. That is your x coordinate, everyone. Now I'll give you a good way to remember. Now, if you actually see this equation, this is an equation of a cycloid. If you can solve this, x minus v0 t whole square plus y minus v0 by omega whole square. This turns out to be v0 by omega whole square. This is an equation of a cycloid. If you look at this, this is an equation of a circle whose center is moving. This is equation of a circle whose x coordinate moves with constant speed. This can be compared to a cycloid. So this trajectory which we get so if this actually comes in the exam, if you remember the cycloid thing, it becomes much faster to solve. You can skip all this integration. So in this circle, right? So this thing which is going on, so this whole problem behaves as if we got a circle here of radius radius r, and this is going with a circle v naught and rotating with omega. And you can clearly see as it is going, the center is moving here. So you can take the coordinates like this. So at this point here, so this center will be vt, comma r. And you can clearly see this distance will be how much then? 2r. At this point, the speed will be v naught plus r omega. No slipping condition, this will be 2v naught. So they can ask you this question also. What is the maximum height of the particle? 2r. What is the maximum speed of the particle? 2v naught. Where v naught is given by e by b. And what is r? R is nothing but v naught by omega. What is omega? Omega is qp by m. So you can just replace like this. You can replace this whole thing equal to a particle going with v naught on a circle. So initially the particle is here, this point A. So I'm asking you to find the coordinates of this particle when it is rolling on the coordinates of this wheel. So you just take horizontal motion and circular motion and finish it off. Is this making sense, everyone? So if you can compare this with a cycloid, saves you a lot of time. But ye data, pata hona chahiye, but these are easy to remember actually. V naught is E by B, you know. Ye omega would be a little messed up, but I think that you would have figured out only from one equation here. Actually, if you look at that omega, right, it is the same thing as this, isn't it? 2 pi m by qb ka omega, if you see, you get the same omega there. It's not actually that different. So if you can mug up this omega and v naught, question is straightforward. It has becomes a circle of radius r going with with speed v naught and omega, and radius of the circle is v naught by omega. You can find literally everything. Coordinates aa jayega. Maximum, they'll try to ask you this only. What is the maximum y coordinate of the particle? 2r. What is the maximum speed of the particle? 2v naught. Is this clear, everyone? It's a pretty good question there. Yeah, it has little calculus, but like I said, physics got over here, ax and ay. Then it is just a matter of integration. All clear with this? Take a break, come back with 7. Any doubt so far, please ask me. Anything that you're not clear in this? Especially the
Yes,
last
sir,
part is
small doubt.
important, where you can compare this with a cycloid. So,
हाँ sir, उसी में I doubt in the comparison वाला part.
which
Sir,
one?
at the topmost point you said the velocity is 2v naught. But we
Yeah.
can see that at the topmost point there is no deflection. So v naught नहीं होना चाहिए E by B.
अरे deflection, if there is no deflection, it'll go straight रे God. Deflection है तो इसलिए नीचे आ रहे तू ना.
Straight तो जा रहा है ना at that point. फिर बाद में जाके वैसे होता है.
So you mean to say at this point, if they're exactly equal, it'll go straight line, right? Why will it take a turn? There is a force, that's why it is taking a turn.
So then any point if it is like this, it will go without deflection, no? So
God,
again,
what do you mean by
anything
no
is right.
deflection? What do you mean by no deflection? Okay,
No
according
deflection
to your
is possible.
logic, particle is there, projected with speed v horizontally, gravity is there. Perpendicular, na? No deflection, right? सीधा जाएगा.
नहीं sir, नहीं.
Then the next moment, velocity has changed, right? Velocity क्यों
yes,
change
yes,
हुआ?
yes.
Because there's an acceleration. Why there's an acceleration? Because there's a net
Makes
force.
sense. Makes sense, sir.
God. Just because you saw horizontal, no deflection. Chal, take a break and come. 10 minutes में आ जाओ.
Okay, sir. Bye bye.
Yeah. Bye bye only. आ जाओ 10 मिनट में.
I think I'm
Sir.
coming only 10 minutes बाद.
हाँ कुछ बोलो ना.
Sir, I did not get the trajectory वाला part. Like, why was the trajectory like? ऐसा क्यों था? I thought कि वो y-axis के along जाएगा.
है नहीं रे देखना. How is a magnetic force? Magnetic force is always pulling it inside.
हाँ,
देखो F
initially
magnetic.
velocity हम like initially velocity 0 था. Electric field
It
से
will go.
y-axis के along आया.
हाँ, but as the speed increases, the magnetic field will start dragging it to the right side. देखो, these components Fm. But as you go higher, what will happen? Speed will keep on increasing. As you go faster and faster, magnetic force becomes more and more strong.
But like when y equal to 0 पे वो वापस से rest पे कैसे आ गया? Where at y equal to
अरे,
वो जब ऐसे
work done by electric field is 0. If you go to the same height and you come back to the same height, the work done by electric field is 0.
Yes.
तो
Okay.
जितना एक्सेलरेट किया इतना डिसेलरेट भी
Decelerate
करोगे,
कर दिया. हाँ ठीक है. Okay. हाँ समझा. Thank you sir.
एनर्जी कंजर्व नहीं होगा ना इफ इट क्रॉसेस दैट बॉर्डर.
हाँ. Yes.
Yeah. Hello everyone, Cam's on. So that is on a force on a magnetic force on a moving charge. The next thing, now there is something called a cyclotron that was removed from the mains portion, so we'll not be doing it. बाद में देखते हैं एडवांस में है नहीं है उसका कुछ क्लैरिटी नहीं है so when it comes we will see, so not much, we will see then when it comes, but mains method is not there. Force on a current carrying wire. Other scams on. So if you take a current carrying wire and electrons are going with the speed of v drift. Now if you take a thin section here dx, so vd is the drift velocity, n is the number of electrons per unit volume, and I hope you remember from current electricity, I is equal to NEA v drift. So if you take force on one electron, that will be EVD cross B with a minus sign. And if you take the force on a dx segment, then you should take all the electrons in the dx segment, which is n into a into dx into minus e into v drift cross b. This is all electrons in dx segment, the free moving electrons basically. I should say number of free electrons per unit volume. These are the electrons which are responsible for the current. So now when I combine this, I'll get force is equal to that NEAVD becomes current. Remember, current flows in the opposite direction of the electrons for motion. So if the electrons are going right, the current is actually flowing to the left. So this becomes NEA V drift into dx bar cross B. There, so this is your final formula. So the force on a dx segment is given by I into dl bar cross B bar. This is a force on a dl segment. And dl bar, the direction of dl bar is along the current. Whichever direction the current flows, you take the dl bar, small thickness in that direction. So this is actually also derived from QB cross B only. Have a look at this. Clear? Now I'll just, so if you have some random wire like this, carrying current I, so if you take a small piece here, dl, and it is in the presence of a magnetic field. Again, same thing, dl cross b. So here, put your hand along the current, right? So put your hand along the current and go towards the magnetic field, same direction there. So you will get the force. So here, how is the force ka direction? So just like QE cross B. So Q ka place may have DL and B ka place may have B. So if you look at the force on this, DL cross B, the force on this small segment would be DF this way. I hope the direction part was clear. It is exactly like QE cross B. So V ka place mein current is there, B ka place mein B is there. So now, so if you have some random wire like this, right? And if you take small segments, let's say this is DL1, DL2, DL3, so on till DLN. And if you try to add all these forces, let's say there's a magnetic field B in the region DF1, DF2, DFN, that force on the curved wire would be summation I, current is same in all of them, I DL1 cross B plus I DL2 cross B, so on, plus I DLN cross B. So I can take out all that common DL1 bar plus DL2 bar, so on till DLN bar cross B bar. This simply becomes I into L AB bar cross BB bar, where A is your starting point and B is your ending point. This is also called as projected length. There, your projected length is back. So force on any random curved wire, you can simply take the ends, join the ends. You can treat them like a single wire AB and finish it off. But remember, all this time, projected length, projected area, all these things work only when the fields are uniform. So this is valid when B bar is constant. If B bar is changing with position or time, position, you can't do this. Time is still fine. You won't be able to take out common if it's changing with position. Is this clear, everyone? So I'll just show it again. So if you have some random curve like this, A and B, current is I in the wire. There is a magnetic field B. You can replace this entire curve with this thing, the projected length. There, I think the projected length and area, this I think is already the fourth time, I guess. First time you saw in fluid mechanics, surface tension. Then you saw an electric flux. It's coming again. Force on the curve is I, L, A, B bar cross B bar. If you think about it, this thing, right? F is equal to I, L, B. If you take F by L, which is I into B, which is constant. Can you see the resemblance? This looks like surface tension. Surface tension S is also force per unit length. So technically speaking, the equation doesn't care whether it is surface tension or magnetic force, because magnetic force per unit length is I into B. Current in a wire and magnetic field region is constant. So mathematically, they will look identical. I hope you're getting this thing. So this looks like surface tension. Please have a look at this page. There, this is the second formula you learned. F is equal to IL cross B. And if the B is constant, the only thing that matters is your entry point and the exit point. It doesn't matter how the current actually flows. You only need the initial and the final. Let's see a question. Let's see a question. We got a disk with some resistance. Radius is R. This is point A. This is a O. This is B. So you're sending current I from A. Now in this process, since there is non-uniform, the current will go however it wants. So current enters it and comes out from this thing. That AOB is 90 degrees. And all this is present in presence of a magnetic field. There's a magnetic field B in the region. Find the force on the disk. The current enters at A and spreads out and leaves from B. You can't tell how it is spreading out. It's a non-uniform shape with respect to A and B. Get this. It's an easy one. I could have taken a solid sphere also. Answers? Yeah. So you are connected, right? Adrit, I can see you. Now, what is the catch here? Now, agreed, current is going in random directions, but if I take this current as I1, this current as I2, and this current as IN, now for no matter how the current goes, the projectile length for all of them is same, isn't it? The force, for all the currents, the projectile length is the same. Because for projectile length, what matters is the initial and the final point. For all current paths, the projected length is the same. Which is AB bar. Means you can replace this entire thing with a current wire I going from A to B bar, right? Whose length will be R root 2 and the magnetic field is B bar. So I L cross B. So the force would be this way, which is I into R root 2 into B, and the direction would be I cap plus J cap by root 2, a unit vector. Check it out. The I root 2, R root 2 be cos 45, sin 45, I cap and J cap. So that's a unit vector. It will be along the XY plane. Clear with that? Next one. Next one. We have a current wire. Y is equal to x square. This is the wire. This wire is carrying a current I. And in the region, the magnetic field is given by B is equal to B naught x minus K cap. Non-uniform field. Find the force on this parabola up to 1 meter. Let's say this wire ends here at x is equal to 1. Now you can't use projected length. Field is not constant. Find the force on the parabolic wire. From x is equal to 0 to x is equal to 1 meter. Let's get this. Try to, I'll give you 2 minutes. Any answers?
Yes, sir, I got it. I'm just
Hmm.
typing that thing in the chat box, so you have to type.
तो करो ना, इतना बोलने से better you could have typed it. Let's see. The first issue here is, at any instant, if you take a small piece, this is your dl, isn't it? But this is your dx. So b is changing in terms of x, but dl is something else. And this is angle theta. So basically, this is your tangent here. And we know tan theta is dy by dx, which is, in this case, it is 2x. Y is equal to x square. So dl cos theta is equal to dx. So the force on that small wire dl is current dlb, and remember this angle is 90. Don't get confused. Theta is the angle between, not this theta, dl cross b, that is an angle between dl and b bar is into the plane. Dl bar is perpendicular to b bar, so that will be sine 90. But dl is dx by cos theta, and b is b naught into x. So it's easy actually, बस इतना ही करना था. The force on the wire would be I b naught by cos theta did I miss something here? ITL cross B, yeah. So integral x dx. Limits will go from 0 to 1. But what is cos theta? Wait, I can't do this. Cos theta b variable tha. This integration is becoming a little messy now.
So I think that you can write dl is equal to a dx I cap plus dy j cap. And then dy is equal to
Sir,
2f
how
dx.
can we integrate it just like that? A force is a vector, no?
Sir, we have to integrate I cap and j cap अलग अलग.
Separately.
वो भी सही बोल रहे हो. I can't directly add that. Yeah, what he's saying is also right. Right, Ishan, वो करना better idea होगा. So dl would be, so dl cos theta I cap. So basically we'll write this as dx I cap and dy j cap. So force would be integral I dl bar cross b bar dx I cap plus dy j cap cross b naught x minus k cap. This would be integral x dx. What is I cross minus k? I cross k, this would be j cap plus integral x dy j cross k, that is minus I cap. ठीक है? This to limits 1 to 1, I'll get it. Here I'll get stuck. I can find the y is equal to x square equation, I know. So this would be IB naught, and that would be half j cap x square by 2 plus x is nothing but root y. Y ka value also will go from 0 to 1. This x is root y. So root y ka integration, that is y power 3 by 2 by 3 by 2, limits will go from 0 to 1 minus I cap. Substitute the limit, so that's 2 by 3. So IB naught 2 by 3 minus I cap plus j cap, half j cap. You're right, I can't directly add it. That was a mistake. Clear with this? Same question, let's change it a bit. Tan theta I didn't use anywhere, right? Basically, when I wrote I cap, j cap, it didn't matter. Try for this. Same question, y is equal to x square, but let's say this time the field as b is equal to b naught x I cap. It's not minus k cap, I cap. This is the current. Again, same thing up to 1 meter. Let's get this. Remember, all these cases you can't use projector lengths. Projector length makes your life easy. So use it when b is constant. If b is messed up, you should still know how to do it. That's this thing. In this case, you can directly integrate actually. In this case, you can directly integrate. In this case, all are in the same direction. That might be right, Lakshika. Let's see. Others try, I'll give you a minute. Previous page here. We have 3 answers, right? Lakshika, Saina, Aryan, yeah, 3 of you got it. Let's see. So if I take a small segment here, DL, now B is this way. Now the angle matters actually. So DF would be I DL cross B, that would be B naught x sine theta. So at this point, if you take a tangent, this would be your dx. Tan theta would be dy by dx, which is 2x. So this is I, and dl is nothing but dx pi cos theta. You want to get everything in terms of x. So this is b naught x sine theta. That will become tan theta. So I b naught tan theta is 2x. So that is 2x square dx. All the forces will be in the same direction minus k cap. 2 ib naught integral x square dx from 0 to 1. This was easy. There, have a look at this. So the main catch in this question is b is changing with x, so we have to take dl ka component. You have to get the dl in terms of dx and then solve. Have a look at this. Clear? Next one.
Yes, sir, clear.
Regular hexagon, side A. Here current is flowing like this. Here current is entering here and current is leaving here. So all wires have uniform resistance. Find force on the hexagons. Easy one. Yeah. Yeah, first one is 0. Now, if you remember the projector length ka concept, what did I say? What is the projector length? The point where the current enters and current leaves. Now, it's a loop, right? Current is leaving and current is entering. So, what is the projector length? 0. Isn't it? You can see and tell projector length is 0. This thing, what is the projector length? This is the projector length. This is the same as the disk question. But still, you want to solve it independently, you can do that. So IL cross B, this is how the force would look. This would be IAB, 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 IAB. IAB. And IAB. You can see that. So in this case, the F net would be 0. But you can also see closed loop has 0 projectile length. Now in the second case here, the catch is the current here will be 2I by 3. Current here will be 2I by 3 because there are uniform wires. There's a 4 arc resistance on the top and there is a 2I by 3 resistance at the bottom. So if you actually try to calculate, you will get the force I by 3AB. You can take the I cap, J cap components and solve this. This would be like this actually. They won't cancel out. You can actually find those angles also, meaning you can see that would be, I think, 90, 90, 120. How much is this? 60 degrees.
Sir,
Oh, alright.
instead of this, you can just take projected length for the two different wires now.
I
Or
know,
wire
God, I know.
one.
I know. Ishan, I
Okay.
told you that in the beginning. You are not listening. So patient. Pata tha. I was just showing you that is another way to do work. You didn't listen to that.
I was solving, sir.
Getting it? So you could have done this also. Currents as a split hoga. So then you take each segment and finish it off. This would go long, but this is a way. Getting the currents wouldn't be same in the upper and the lower thing. And then you can simply take A to B. Now this question is as good as the disk, isn't it? You did disk only, which was having currents in any random directions. Hexagon is much more beautiful than that. So you could have just taken this length AB as a projected length. The force would be I into the length AB cross B. And if you see this length, this will be root 3 times A. Hope you remember. This is your projector length. So that would be the faster way. Clear with this? This would be a standard question, huh? Mains or bits level question. This is find the force on the loop. Let's see one more. Turn in the page. Any doubts on this? Vidyut, clear with this? Swastika, clear? Udayan? Neil? Great. Let's see the next one. We have a current loop here. Elastic current loop. K is the elastic constant, just like spring constant. So this thing will stretch like a spring where the spring constant is K. Means if you apply tension force F or tension T, T will be equal to Kx, where X is the elongation in the wire. The magnetic field in the region is B outside. Now you suddenly started sending current I. This is the top view. M is the mass of the ring. R is the radius. Initial radius. The first question is find the new radius when current passes through it. The second thing, if the system is in equilibrium, find time period for small oscillations. The system is settled down, and let's say you just change the current a little or change the magnet a little, or you just pulled it and left it. Find time period for small oscillations. Let's get the first part. First part is fine. Second part is an interesting. This would be a good question, advancement. The two parts. Advancement, I'll ask you the time period directly. Remember one thing, if a system is in stable equilibrium, let that system be anything, electric field, magnetic field, gravitation, SHM will be there. You just need to use the word small oscillations, suddenly it becomes SHM. Let's get the first part, everyone. Just to give an idea, how is the magnetic force on the loop? I L cross B. Is it outside, isn't it? So the whole loop is being stretched. So radius badega. So what is the new radius? Now, if you disturb this a bit, it will start oscillating in and out. It will be fluctuating in and out. What's the time period for small oscillations? Let's get the first part, everyone. Anyone didn't understand the question, please ask me. Try. I'll give you 2 minutes. Just give it a try back in a minute. Who is keeping FP in equilibrium? The elastic force on the spring and the magnetic force? When the spring gets stretched, it is trying to compress, right? It's like a spring, isn't it? If magnetic force is not there, it won't stretch in the first place. It will be a natural length. So 2 pi r is a natural length. The moment you applied current, it stretched. Give it a try. Adrit, get the first part, no? First. You got the first part, then you'll get the second part. हो गया first part. कितना है the answer? Let's see the first part.
Sir, 2 minutes, please.
हो गया already 2 minutes देके बहुत time हो गया. चलो, I'll give you 30 seconds. Since physics people are good people in general. Yeah, when it comes to magnetism, normally electrostatics may very evil people. So, हो गया.
हाँ सर कुछ तो मिला सेंड.
Yeah, ठीक है ना, you can check रे. Why are you stopping me from doing? By the time I do, it will take another 1.5 minutes. इतना तो type कर लो. See, so this was the circle initially. When it expands, again I'm exaggerating the figure here. If you have taken this small segment here, remember, theta won't change. This is d theta. So initially, if your length is r d theta, this length will be r plus dr d theta. Right? Or let me call it as simply r final d theta. Where r final is the, I'll just put r dash better. Now, if you look at the whole elongation in the wire, the whole elongation is 2 pi r dash minus 2 pi r. And we know tension is nothing but the spring constant into elongation. So that would be 2 pi k into r dash minus r. That is your tension in the string. Now on that small segment, if you draw the FBD, if you look at the forces here, so the tensions are pulling this way, tension and tension. And this would be the current I into the new radius r dash d theta into b. This we have done in circular motion. This thing came multiple times, I told you. I think first time we saw in circular motion, then we saw in elasticity, then we saw in surface tension. Then we saw this in waves also. This is the fifth time. This angle would be d theta by 2. So from here we'll get 2t sine d theta by 2. This should be equal to I into r dash d theta into b. For small angle, sine theta will be theta. This would be tension, which is 2 pi k r dash minus r is equal to I r dash b. So I will just write that 2 into d theta by 2 is equal to I r dash d theta, 2 goes off. Bring all r dash to one side. This would be 2 pi k minus ib is equal to 2 pi k r. So r dash is equal to 2 pi k r by 2 pi k minus ib. Now if you look at this, if the denominator becomes 0, meaning this will stretch to the infinity, meaning this will never stop. So they can ask the condition this also. Find the condition for stable equilibrium. That is 2 pi k must be greater than ib. Because what is happening, as the wire expands, the length of the wire is also increasing. So you're getting actually more and more magnetic force because the length is increasing. So there is a possibility, right, that this will never stop expanding, or it will just keep on expanding forever. In an ideal case, it will, it will like keep on expanding. Real case, it will somehow break at some point. Check it out. I hope I didn't mess up the calculations. Looks right. Clear with this? This is the same thing which we did before also. The only thing, the radius is r dash now. That's your new radius. Now, how do you find the time period for this? Try. I'll give you another minute or two. So now if you disturb this, so from r final, if you disturb it a bit and leave it, it'll start oscillating. Find the time period for small oscillations. Anyone not clear with any particular step here, please ask me.
The second question क्या था?
Time period for small oscillations.
Okay.
This thing in equilibrium mein hai, and if you disturb this by x, find the time period for small oscillations. Meaning, if I show you the diagram, initially it was here, r. Once you send the current, it became here. R dash, when the current is passing. Now what you're doing, you're just pushing it slightly outside or inside by another x. Mass diya na m, mass is m. It's given mass is m, initial radius r. So if you pull it to green level and leave it, so it will start oscillating now in and out. How do you find the time period for small oscillations? Try. It's a good one. See, the idea here is, so when you pulled it little, now the tension T, now this force will become how much? I into that R dash plus X d theta into B. This is also d theta by 2. So on that small segment, now the forces won't be balanced. So dF, this is the net force on the d theta arc would be 2t sine d theta by 2 minus I into R dash plus X into d theta into B. And for that small piece, what is the mass? So mass of that small piece will be theta by 2 pi into m, unitary method. Clear with this? Now, and what is the tension here? Tension would be spring constant k into the change in length, which is 2 pi r dash plus x, that is a new length, minus natural length is 2 pi r. Be careful with that. It's not r dash, you should always measure from the natural length. And if I subtract this, so tension would be 2 pi k r dash plus x minus r. There I got everything. So substitute. So F net is equal to mass into acceleration. So minus dm into a, minus because we take acceleration outside, but the net force is inside. That is the meaning of a restoring force basically. Minus dm into a is the net force is 2t sine d theta by 2. I'll just write it down again. Minus the magnetic force is I into r dash plus x into d theta into b. Perfect. And substitute. So this guy would be theta by 2 pi capital M into a. 2 tension would be 2 pi k r dash plus x minus r. For small angle, sine theta is d theta by 2 minus I into r dash plus x d theta into b. 2 will cancel. D theta will cancel everywhere. You end up with ma by 2 pi. This guy would be 2 pi k. I already know r dash का value, right? तो substitute कर सकता हूँ. I already know 2 pi k minus ib is this. I need to substitute here. 2 pi kx 2 pi kx minus ixp plus 2 pi k r dash minus r minus I r dash b. Actually, these two terms will cancel out. That is how we got from the equilibrium, isn't it? 2 pi k r minus r dash is I r dash p. Basically, we are taking change in forces, and so acceleration would be 2 pi by m minus sine into 2 pi k minus ib into x. So this term is your omega square. Time period is 2 pi by omega. Isn't that what SHM does every time? You bring in a chapter, it does all the work, and then it will come and say, there I am SHM. Main idea is here. Please check it out. I think if you got this equation, job's done. This one and this one. It's just a matter of substituting and getting a in terms of x. So when you pull it out, you did two things. You change the spring force. You also change the magnetic force. The net resultant force should be equal to m into a. Any doubts on this? Clear? Next one. Last one for the day. We have a capacitor with a switch. This is capacitance C. Here we have a rod. Gravity is there. This is a rod of mass m and length L. So it is held at rest by some supports. The rod is initially at rest. Now this capacitor, this has charge plus Q and minus Q charge, and the magnetic field is B. So yeah, perfect. Gravity is also there. Now the switch is closed at T is equal to 0, and the capacitor suddenly discharges. This is a vertical rail, this is a front view. The rod is held at rest on vertical conducting rails as shown. When switch is closed, now since there is no resistor, it will discharge pretty fast. Capacitor discharges instantly. It does take, very small time in nanoseconds. So find the maximum height of the rod. So after this, something happens and the rod starts moving. Find H max of the rod and the heat produced. This is a pretty good question. These are the kind of questions which are tough to think and figure out, but easy to solve. You got the idea, it will be done like 5-6 steps, but think. Anyone didn't understand the question scenario, please ask. Think for a minute, then I'll explain the question. You think why the hell it is moving in the first place. You figure it out. Then let me explain it to you. Someone gets an answer, please type it in the chat box. So the first part of the question is figuring out why the hell is the rod moving. So why is the rod moving? The moment you close the switch, what happens? Capacitor discharges. If capacitor discharges, means there's a current. And if there's a current, right, there's a magnetic force that is actually moving the rod. So in these kind of questions, what is the word that should hit you? Can you tell me which word in this question is giving you a hint? Yeah, this word, instantly. Whenever something happens pretty fast means what? It's an impulse-based question. Getting it? A large force is given in a short amount of time. So यहाँ पे क्या हो रहा है ना? Since you're discharging a charge q in a very small time, the current I will be q by time, where time is tending to 0, I will be large. Since I is large, there will be a huge impulsive force for a small time. It feels as if someone kicked the rod. So that's what the rod will think. Someone kicked me out. So you can ignore mg for the small time dt. It becomes an impulse problem. That's the idea there. So the moment the switch is closed, current I will flow through the circuit. I will be dq by dt. dt tends to 0, so I will tend to infinity. So large current gives large magnetic force. This is a large impulsive magnetic force. I'll just say impulsive, that itself means large. Impulsive magnetic force. So the force on the rod will be I into L into B. But what is force? dp by dt, rate of change of momentum. So dp is equal to LB integral I dt. Now I don't know current, I don't know time, but I know what is the charge. So this is change in momentum, which is m into change in velocity is LB into q. Integral I dt is charge. And you're done. So velocity v will be qb by L by m. Therefore, h max will be v square by 2g from the initial position. And what is the heat produced? Heat produced will be initially how much energy is there in the capacity? Q square by 2c. And what is the energy of the rod? Half mv square. The difference must be heat produced. Energy is not conserved in this situation. Whenever you discharge something instantaneously, you always lose energy. Like I said, the main idea is once you got what is happening, it's pretty easy to solve in 3-4 steps. And the main idea is that the huge current is behaving like an impulsive force. Clear with this?
Heat can I explain again?
What is the heat? Initially, what is the energy stored in the capacitor? Q square by 2c. Once you close the switch, capacitor energy becomes 0. And the rod has a kinetic energy of mv square, meaning some part of the capacitor energy became kinetic energy. The balance must be heat, right? Make sense? This was the energy of capacitor. This is the kinetic energy of rod. Okay? There, so that is a part of it. So next class when we catch up, we are going to do torques. Now, if there's a force on a wire, it means it can also rotate. So there, so do make sure to go through this. Pretty good questions, so try them again once more. Okay, so with that, we'll wrap up for the day. So we'll catch up on Friday again. Same time, we'll continue from here. So we should be able to wrap up the torque part next class, and maybe we'll start the introduction for Biot-Savart's law also, the magnetic field due to a current wire. Okay, with that, we'll wrap up for the day. So any doubts in today's class, anything else, stay back and ask, always feel free to leave. So take care, stay safe, and see you on Friday at the same time.